Okay, this one says solving an equation that can be written in quadratic form, and then I don't know what it says after that. Supposed to solve it, but they want you to write it in quadratic form. Okay, now remember, quadratic form is, ax squared plus bx plus c equals 0. Now I see a y squared, but I also see a y to the 4th, and I don't see an equal to 0. So that's the first thing I'm going to deal with. I'm going to add 35 to both sides. That way over here it cancels out and this side becomes 0. So what I'm going to have is y to the 4th minus 36y squared plus 35 equals 0. And okay, let me go back over here again. When you look at this x squared right here, x squared, this right here is x to the 1st. 1 is half of 2. Well, when you come over here and look at this, y to the 4th and y to the 2nd, 2 is half of 4. This guy here could be written as a y squared minus 36 y squared plus 35 equals 0. Actually, y squared like this, y squared to the 1st. Because you've got a x squared and an x to the 1st. So I've got a y squared, and a y squared to the 1st. I didn't mean to put this guy right here, sorry, should have been here. The point is, I can factor this. I can simply split my y to the 4th to be a y squared and a y squared. That way, when I do outsides and insides, if I were to FOIL back, my outsides would be a y squared and my inside would be a y squared, which would add up to a bunch of y squareds in the middle. And then back here I got 35, so my last times my last has to be 35, so it's either 1 times 35 or 5 times 7. Those are the only factors of 35. But it has to add up to a negative 36. So that's going to have to be a negative 1 and a negative 35. Negative 1, if you take negative 1 times negative 35, that equals a positive 35 for my last term. And if you take a negative 1 and add it to negative 35, that adds up to a negative 36, which is my middle. Because outsides and insides you have to add up. Now, I'm not done factoring because that's a difference of 2 squares. I can factor this guy a little bit more. He's a difference of 2 squares, and he is going to factor into what they call conjugates. This guy's still here. This guy's still a y squared minus 35. It's a difference of a y that's squared, but 35 is not a perfect square. 1 is a perfect square because 1 times 1 is 1. If there were a 4 here, that'd be 2 squared. If there were a 9, that's 3 squared. If it was a 64, that'd be 8 squared, right? So for this y squared, I'm going to split it to be y and y. And for this 1, that's going to be 1 times 1. But the outsides and insides have to cancel. So one of them has to be a plus and the other one has to be a minus. And keep in mind this is still equal to 0. Now, I have 3 factors now. So if I go back to that old, if A times B is equal to 0, then that means either A is 0 or B is 0 concept. I'm just bringing in a third player now. Now I've got if A times B times C equals 0, then that means either A is 0 or B is 0 or C is 0. So this is my A, this is my B, and this sucker's my C. So I'm going to set each one of those three factors equal to 0 and solve for y. Okay, so I'll try to use different colors here if I don't have enough. Let me use my highlighters. So I'm going to take this guy first, and I'm going to say, okay, what if the y plus 1 is a 0? I would subtract 1 on both sides to cancel that out. So one answer is -1. Then I'm going to take the next factor, which is y minus 1. Set that equal to 0. I would have to add 1 on both sides to cancel that out. So I get y is equal to a +1. And then last but not least is this guy. Now, he is a quadratic that can't be factored. So I can either use the quadratic formula or an easier way, since you only have the squared variable, like see how I have the x squared and then normally there's an x to the first? Well, here we have a y squared, but there's no y to the first. When there's no y to the first in that kind of a quadratic, you can simply solve by taking square roots. I'm going to use that because that's going to be easiest. Hey, if you want to use the quadratic formula, knock yourself out. You can. It won't factor, however. Factoring's not working. So that cancels. I get y squared is equal to 35. And now what I'm going to have to do to solve for y is get rid of the squared. And to undo a square, you square root. And then I got to square root the other side. If you square root a y squared, it's just going to leave you with a y. And then here's the tricky part. When I take the square root of 35, there's actually going to be two possible answers. Either the positive value of whatever the square root of 35 is, or the negative value of the square root of 35. And I'm reading in Alex, it says if there is more than one solution, separate them with commas. And I'm looking at their little box here, and they've got a choice with a square root in it. So they don't want me to grab my calculator and take the square root of 35, because that's not a perfect square. Let's see, 35 comes between 25 and 36. 25 is 5 squared, and 36 is 6 squared. So the square root of 35 is 5 point something or other. It's probably like 5.9 something, 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 something. But they just want me to leave it in radical form, and I can't simplify that, so it's going to be the square root of 35. But there's two possible answers, positive or negative. So when I come up here to put in my answers in this box right here, it says to separate your answers by commas. I'm going to type in -1, comma, +1, comma. I'm going to have to hit this little symbol here so the square root sign pops in. So click on that. And then type in, there'll be a little box here, type in 35, comma, then I'll hit a negative sign, then I'll hit this little symbol again, little box inside, and put the 35 in there. And that's what should go inside that box. Hope that helps.